Greetings everybody, welcome to this new video on Shumbafoot, where we're going to look at some data and analyzing data, presentation of data, which is basically the thrust of statistics. As you can see, we're going to be looking at what we call correlation and regression. We're going to be looking at some scatter diagrams, which you can see in front of you there, and also the lines that we're going to be drawing, so that we get to see the linear degree of the scatter diagrams that we're going to be analyzing and translating the data that we're going to be using into those scatter diagrams, preparation of those scatter diagrams, and also the graphical representation of the regression, and also going to be looking at how to calculate the correlation, the correlation coefficient. So all that is going to come very soon as we start this video, so just sit back and relax. If you have somewhere to work on as you go through this video, some notebook or whatever, you want to just jot down some notes, so that when you attempt the question that I'll give you soon after the example, then you can get on with that. So let's get started with the video. Okay, so for this example, I'm going to take you through it, and then the next example you're going to start by working out on your own, and then you compare your answers with what I would have prepared for you, the answers that are there. But make sure you're also honest with yourself, so that you get to understand these things. Okay, so just read through the summary of the situation that we're dealing with in this example, and then I'll just read the questions. Draw a scatter diagram and comment on the correlation. That's the first thing. So we have that table, which are the results of a certain class. Just 8 results were sampled and compared with the time or the period that each student decided to spend whilst preparing for the exam. That's basically the idea behind it. So that's what we're trying to investigate. What's the relationship between the time spent whilst preparing for the exam and the mark they have received? Prove your proposed correlation. So we're going to do that mathematically. You'll see how we calculate that using the product moment of correlation, and then we are going to draw the regression line. That's I'll show you. It's basically y is equal to mx plus c, but in another form. And then estimate the mark that a student will likely get if they spend 100 days preparing for the mock exam using the regression line. So we're going to use the regression line to find or see or to estimate the mark that they will probably get if they take 100 days to study. But this experiment, this investigation, we won't call it an experiment, but it's an investigation, is basically something that is a bit off in terms of some constants that we would need to ensure that we have a perfect relationship between the two. Otherwise, other factors might kick in that may distort the effect of the relationship between the variables that we are looking at, which are the time and the mark out of 100. So we need to make sure that all other things being constant, in economics they call it ceteris paribus, which is a Latin expression, all things kept constant. So we are trying to make sure that's what we are looking at here. Although the example itself is a bit difficult if you look at it practically, but for our case we're going to be looking at it as it is, all things being kept constant, so that we get to understand the concept of this thing called regression. Okay, so what you're going to start by doing is, rather before we start, you can have some calculators that actually assist with proving your answers. We have some other smart scientific calculators that are able to, you can just punch in the values from the table, those first 2 columns, the total days of preparation and the mark. You just put them as x and the y, since they're already labeled in the header there that it's x and y. You do that in your calculator respectively, and then you get your different variables and values that you're going to be dealing with, and the longer route is what you're going to be dealing with right now. But you have a shorter route that you can just do. You don't need to do all of this if you have a calculator. But in the case that you don't have that kind of a calculator, then you would have to do this long route, which is quite good. It helps to sharpen your brain in terms of calculating stuff. So what you're going to be doing is you're going to be adding. So we're going to have the sum of x squared, which is another variable that we're going to need. We're going to need the sum of y squared, and we're going to need the sum of the product of x and y. So we can see 120 squared is 14,400, 170 squared is 28,900, 200 squared is 40,000. So just go on like that, and then you add all those values and get your sum. So that sigma that you see in blue at the header there, it basically talks about the sum. It's not how you exactly write it, but for the sake of understanding, that's why I put it there, so that you get to understand. In the normal case, you just put x squared, but I've put that sum so that you get to understand that the blue is talking about the sum. When you add all those values, you get the final answer, which is in blue. So all those values in blue are basically the final answers after adding all the values in those columns. So what you see y squared is basically 30 squared, 72 squared, and 44 squared, and the like. Then you get your y squared respectively, and then you add all those y squareds to get your final answer, which is in blue at the bottom there. And then for the xy is basically x times y. 120 by 30 will get you 3,600. Which other one? 80 by 30. Yes, 80 by 30 you get 2,400, 2,400. If you say 200 by 90, you get 18,000. So it's just the x multiplied by the y, and then you get your xy, and then you add all those xy's and you get your 73,230, which is in blue. So all those values in blue, if you check even the x, it's the sum of the x, which is 1,170, the sum of the y's, which is that value there. So you get to see what's happening with the color coding that I've put there. So make sure you don't get lost. I've tried to put it in respective colors so that you can get to familiarize with how things are being done. So let's move on to the other segment where we're going to need these sums, these final totals. We need this total so that you can calculate other variables that we're going to use to derive the equation of a straight line. Okay, now let's calculate the different variables that we need. We're going to start with the mean. The mean, we're going to represent it as x bar and y bar, respective for the x, which is the time that was put in by the students to prepare for the exams, and then the y bar, which is the average of the marks that they got, the total marks they got. So that will be the sum of the x or the sum of the y respectively, divided by the number of the sampled the sampled data, which we saw that it's for 8 students, so it means that n is equal to 8. So that's why we are dividing by 8. Then we get our different answers: 146.25 for x bar, which is the average for the time in terms of days, so it's 146 days, 0.25. Yeah. And then we have our y bar, which is around 57.125. That's the average mark. If you put it in percentage, it's basically 57.1% attained by an average student. And then we're going to calculate what we call the SXX, or the sigma squared x. It's basically one and the same thing. That is equal to the sum of the x squared. Now you see where the x squared was needed. In terms of the y, that's the same thing. If you look on the other side, it's the sum of the y squared divided by the n, and then we subtract the average squared, so the x bar squared and the y bar squared respectively, as you can see. Then we calculate it like that. We just substitute the values, as you can see, and then we divide by the 8, as you can see, because that's the number of the sampled quantities. And then if you see, there's some, for the x I put brackets, for the y I didn't put brackets. I'm trying to test you so that you get to understand the effects of those two things, the brackets and without brackets. It's basically one and the same thing, but so that you get to understand that the fraction is on its own, and then if you know the rules of what's called BODMAS or BOMDAS, something like that, that's what we call it on our side. I'm not sure what you call it there where you are, but you first divide and then you subtract in our case. Yeah, so that's what I'm trying to test you also, so that you get to understand that you don't just get used to fractions with brackets, but so that you can just be able to read the fraction and understand what's happening. Then you get your final answers, as you can see. And then the sum, the SXY, we're going to use the sum of XY, which we saw in the last column. That's sum of the XY, which I explained. You multiply the X and then the Y, and then you add all the XY's together, and then you get your sum. And then you divide by 8. Then you subtract the product of the X bar and the Y bar. Because here we're dealing with XY, so we need to say X bar multiplied by Y bar. It's not X squared or Y squared like we were doing. So we do that and then substitute the values, and then we get our answer 799.21875. So that's how we work out these things. There are certain formulas that we use, as you can see, very easy to okay, I don't want to say cram, but you know, you might as well just end up doing that. But usually for students who are in school, you get what we call a formula sheet, which has these formulas on that formula sheet, so that you don't get lost as you calculate. It was a lot of things that you have to calculate, as you can see, but if you have a calculator like the scientific calculators that I was talking about, the smart ones, they're able to do it instantly. You don't have to, all you need to do is to punch in the values, the sample data, and then it calculates everything for you. So yeah, go for it, but this will help you to train your brain to think widely. So do what you can, do what you must, and make sure you get the right answers. Okay, so now we're going to look at how we are going to plot our points on the scatter diagram. Basically drawing the scatter diagram using our different points, our 8 points, for the 8 students that we have used to sample our data. So we have those axes, the yellow lines that you're seeing that are crossing each other, and we should know what they represent. So the horizontal axis is what we call the x-axis. That's why we have that x, and then the vertical axis is the y-axis, which is why we have the y, if you looked in the tables that we are looking at. So the x was the time that was taken, the number of days, the total number of days that each student took was the x, and the exam mark that they received is the y component. So we need to use the table that we had to decide on the scale that we're going to use. Are we going to put it in 10s? Are we going to put it in 40s? Are we going to put it in 20s, as we have done here? You get to decide, so that at least you get a clear diagram. You don't want things to be squashed in a certain corner, but you need them to be to use the ample space that you have, so that you can be able to clearly see what's going on. So we then have those axes, we label them, make sure you label them clearly. And if you are wondering why it's extending beyond the origin to the negative side, as you can see, it's because if you calculate the equation of the straight line, or of the regression line that we're going to be calculating, we're going to calculate it soon, you're going to see that it's actually going to be in a negative. What we call the y-intercept in this case is going to be written as a instead of c. The usual equation is y is equals to mx plus c, where m is the gradient and then c is the y-intercept. In this case, it's going to be y is equals to a plus bx, where b is the gradient and a is the y-intercept. So our y-intercept, which is where the line is going to cross the y-axis, is what we call the y-intercept, and it's the a, and it is going to be in the negative for this particular example. It's not always going to be the case. Sometimes it might be from 20 going upwards, as you can see there. It might cross somewhere there, as you're going to see with future examples. But for now, let's look at our example here. Right, so we are going to look at those points. As you can see, they are scattered. They are not in line, they are not together, they are not bunched up together, they are just scattered. And that's where we get the idea of a scatter diagram. And as you know, with students in a class, you're going to get many different marks. So it's just by nature that you're going to get a scatter diagram in terms of those marks. But as you can see, they are following a certain direction. It's like they're starting from below, from the left, and then they are rising diagonally, going to the top right corner there. But yeah, that's something that you can notice as you describe the correlation of the scatter plot, or the scatter diagram. So we're going to see that we have plotted our points. I think we all know how to plot points. So we're going to be using the table with the x and the y, with the time and the exam mark that we have seen right at the beginning, where we're looking at the question, where you have to read that paragraph, the summary of the question, and then get to answer the question. Those 2 columns, yes. So we're going to use those ones to plot these points with the x and the y respectively. So you look for the x. If it's 120, you then look for 120. You go 120 it's equal to 30, so you go and plot where the 30 is, and you go on so forth and stuff like that. So let's move on and see how we're going to calculate the regression line now that we know how to plot these points, which is very simple. I'm not sure if you should have prior knowledge of how to do that, how to plot points. And make sure that your points are also small, so that I would prefer to use a cross, as you can see, so that you can have a point where the line can intersect, if it does intersect. In our case, we are not worried about a best fit line or intersection of points in the line. We are not looking at that. We are just concerned about the relationship between the line and the points that are scattered all over. Are they scattered so much that they cannot show us the relationship between the time and the exam mark? We're just trying to look at that. So let's move on to look at the regression line. Okay, apologies for I rushed. I was supposed to actually start by looking at the product moment correlation coefficient, which is the coefficient that will help us to see mathematically without drawing anything, just calculating to see how our slope or how the gradient is supposed to look like, or how the correlation is supposed to look like. Yes, not really necessarily gradient, but the correlation in terms of whether it's diagonal with respect from the origin, or it's going to be the other way around. So that's what we're going to be looking at. So okay, we are going to use that equation. R is equal to s xy divided by s, the square root of s xx multiplied by the square root of s yy. That dot, it basically means the dot product. If you know what dot product is, it's basically multiplication sign. It represents the multiplication sign. So just so that you don't confuse the x and the multiplication sign, so we put the dot. Okay, so don't confuse the comma, which shows the decimals. Yes, don't confuse with that. So as you can see now, when I substituted the values, I then put the multiplication sign so that you don't get confused. Then we get our answer is 0.824. So the correlation actually ranges from -1 to +1. So our values have to be between that. So it's -1 to 0. It basically means it's in the negative. It's a negative correlation. Then after 0, going to +1, that means it's a positive correlation, which means yes, it's sort of with respect to the origin. It's pointing somewhere to the origin, or not necessarily to the origin straight away, but somewhere like that, and then going towards the right, the top right corner. And then for negative correlation, it's like starting from the not necessarily exactly from the top left, but from the left side, and it runs down towards the right, the bottom right corner, something like that, so that you visualize it. You're going to see some examples later on as we summarize this, when we summarize this correlation topic. So what you see is that our value is 0.824 to 3 significant figures for accuracy, but we're going to see that it's 0.8. That's the main point. If we round it off to the nearest one decimal place, it's 0.8, and that's closer. That's very close to +1, which means it has a very good positive correlation. It's positively correlated, as you saw with the points. Like I was saying, it's like going towards the top right corner with respect to how we are seeing it. It's like the top right corner. So that's what we mean by that. It's 0.8. It's closer to +1, which means it's a very good. It is a very good positive correlation. But if it was like below 0.5, then it means it's slightly coming closer to a negative correlation. But in our case, it's a very good positive correlation. It's even close to a perfect correlation. It might be hard to visualize it as you see it with the points, because they're a bit scattered more than what you would expect. But that's basically it. We're looking at the scatter diagram, the correlation of the scatter diagram. There's also what we call the correlation of the line, which we call the linear correlation. Yes, but we also have a linear correlation of the scatter diagram just by looking at the scatter diagram. We're going to look at the line as well, which is what is normally done with many people. This one of the scatter diagram is a bit new, but it's not really hard. It's more or less the same thing. Okay, some people might see that x, the sigma squared x and the sigma squared y, they'll start thinking it's the variance of x and the variance of y. Well, it's not really like that, but yeah, if that will make you understand it. But don't confuse yourself with that variance, but it's sort of related to that, because if you get to see, the other one is the sigma y and the sigma x, and then in this case we have the sigma squared x and the sigma squared y. So if you think in the lines of standard deviation and variance, you might see that there's some relationship. That's why we put it like that. But some people prefer to use the s, some people use the sigma. It's more or less the same letter, s being the common English letter or European letter, is the Western European letters, and then the sigma is the Greek. Yeah, it's more or less the same letter but in different languages. Okay, now we're going to look at the regression line. You can read the note that's there in orange, but I'm not going to read it so that we just move with time. You can read it at your own pace and your own time. So what you're going to be calculating is basically what I called the y-intercept and the gradient. So our b is going to be the gradient. I think some of us know the calculus method of finding gradient, which is the change in y over the change in x, which is change in the vertical axis over the change in the horizontal axis for the variables that you'll be looking at. So that's more or less the same thing that we're going to be doing here, which is the sxy over the sxx being what we call the change in y over change in x, or delta y over delta x, or dy over dx, whichever way you do it. And then you put in your values, which we calculated long time back. I think some of these values shouldn't be confused. It's just basically what you calculated. You just take that, or what you find in your calculator, if your calculator is smart enough to do that. And then you find your answer, 0.47 whatever, and then you also then use the equation that we are supposed to use, y is equal to a plus bx, so that you find your a. You rearrange the equation so that it becomes a is equal to y minus bx. And because we are trying to use some accurate values to get the regression line, because we're using scatter diagram, so our points are just scattered all over. Not all of them are on the line, so we want to make sure that we're going to use the one which will be on the line, and the point that we are certain will give us that will be the point of the average of those values. It will usually give us that straight line, so we use that. That's why you see that it says therefore y bar minus bx bar will be equal to the a. Alright, then our a, we just substitute the y bar, which is at 57.125, minus the b, which we already calculated, which is on top there, and then our x bar, which we calculated back there, 146.25 days, not years. It's in days. And then as you can see, our a is in the negative 11.6946, which is why I had to extend the y-axis and the x-axis into the negative quadrant. Okay, if you look at the Cartesian plane, you get to know what those quadrants are. There's a positive, 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 negative, 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 and negative, positive. You get to understand all of that if you look at the Cartesian plane. But what we're using right now is the positive, positive. But I had to use also the negative, negative. That's why I extended. That's why you see the negative 20 and the negative 40. Just so that you understand that. So that's why it reaches negative 20, because negative 11 is before negative 20. So that would be a safer way of doing it. So let's get on with the next step. So what we do is we now substitute the a and the b in our equation, so that becomes y is equal to the a, which is the negative 11.6946, and the b is 0.4706x. So that's how we do it, and then we substitute that to get our actual equation for this specific example that we're dealing with, or this specific question that we're dealing with. And then now what we want to do is to find at least 3 points that fall into that regression line, because we know that these other points, we cannot trust them. They might not fall into that regression line. We don't know where the regression line is going to be. We don't know which points are going to fall on that line, so we need to make sure that we have certain points that we're going to have on that line. And because y is a function of x, is equal to a function of x, and our function of x is the a plus bx, as you can see with our negative a and our positive b. So we just plug in our x according to what we see in the scale at the horizontal axis, which is the ones that we're going to be using to substitute the 40, the 120, and the like going forward. So just get used to that. We're going to be plugging in using what's on the number line on the horizontal axis, not in the y-axis, because we're looking for the y. So if we get the x and then we look for the y, we get the y, and then we plot our point. We're going to use green dots so that we don't confuse ourselves. At least 3, so that we get a better accurate answer. But usually not less than 3, because you can't come to a conclusion with 2 points. It's a clear rule in science and mathematics that you need to know. And again, you see that the x is in brackets, as you can see there. The 40, the 120, and the 200, they are in brackets because they're multiplying with the 0.4706. So that bracket means we're multiplying the x and the b, so that we get our final answer. So don't get confused with that. So let's move on to plot the straight line, and then we find the value when our x is equal to 100. Okay, so as you can see, the green dots have been plotted, the points have been plotted, the 3 points that we looked at when x is 40 or 120 or 200, and then our line has been drawn as well. And as you can see, the line passes through the x-axis and goes down to cut the y-axis in the negative there, before negative 20, which is around negative 11. So it's not very accurate, yeah, we know the graphs they're not very accurate. Try to use the graph paper that has boxes so that you get to be precise and accurate. But in this case, it's just for you to get an idea of what's going on. That's the main idea of this, having it on this chalkboard of ours. So this line is basically what we call the regression line. It's trying to show us the correlation of the scatter diagram. It's also trying to show us where the points should be lying. But because we have the scatter diagram, it's not going to be possible. But that's what we are assuming, that if all points were to be in a linear form, they should be on this line. But the line is basically trying to show us the correlation and the organization of the scatter diagram. That's what the line is trying to show us. If there is no correlation at all, as you're going to see later on with some few examples, you're going to see that what you saw at the beginning, very first slide, you saw that there is one diagram which had points all over. They were not forming a certain linear organized pattern, because that is what you call no correlation, a point where there's no correlation when the coefficient is equal to 0, as you're going to see later on. So let's move on. Okay, so we are going to see that for us to estimate this mark for when a student takes 100 days to study or to prepare for the exam, it's going to need those graph papers that I was talking about. Otherwise, if you're going to do it the same way I've done it, on a plain surface without those boxes, you're going to be forced to use the equation to find out where exactly the points or the mark is out of 100, or where the y component is when x is equal to 100. You're going to need the equation. That's what I've done here. The same equation I used to get those green dots is the same one I used to calculate when x is 100. Yes, so I just substituted the x with 100, and then I got the 35.4. It's not exactly the value, but if you round it off, it will be 35.4. So make sure if you have the gradient, the graph paper rather, pardon me, you will be able to get that value easily. But if you don't, then you have to use the equation if you're doing it like this. But you then have to show lines. Usually there'll be broken lines, but yeah, I've just used orange because I have many colors. But usually you have one chromatic pen, so it's a monochromatic ink, so you won't be able to do it the same way I've done it. You'd have to use broken lines, dotted lines, and solid lines to differentiate your lines for the axis and for the regression line, and for those lines that are showing the components that you are dealing with. So that's how we use. So those lines are the ones that help us to reach the final. So where those two lines meet will give us the point where x is 100 and y is equal to that 35.4. So when we draw those lines, we're able to see, okay, so the mark that we're expecting this student to get is 35.4 after they study for 100 days. So that's how we calculate everything. And as you can see with the correlation of the line, we are assuming that because it's 0.8, that was the correlation of the scatter diagram of the points, and then the line as well is positively correlated. We are expecting that because of that very good positive correlation, there seems to be some relationship between the time and the mark that the students get. If they put in more time, they seem to be getting enough marks that are actually good, very good marks. That's why we see that as x increases, y tends to be increasing as well, if we are going to speak in terms of the x and the y that we're looking at, the x components and the y components, the x-axis and the y-axis. As x is increasing, we are also expecting that y will be increasing according to the scatter diagram and the regression line. So that's how we look at it, and that's how we conclude. So we're expecting that this teacher, after they have gathered every information and if they analyzed this and presented it in this graphical form, the teacher is now convinced that the time that the students put in to prepare for her mock exam will relate to how they'll perform in the exam. So if they prepare, it's like if you are baking a cake, if you practice and practice and practice, there's even a saying in English that says practice makes perfect. If you practice and practice and put more practice, you'll perfect your skills and you'll be able to do better than when you started. So that's basically the moral of the investigation we're doing. Let's move on to what you're going to be calculating. So pause the video. Okay, before we do that, let's look at the correlation as a summary, just to summarize everything so that you get a picture of what we're looking at, and then you go on to do to attempt the example that I have prepared for you. Okay, so just to summarize, we're going to see that we have the correlation of the scatter diagram, and then we have the correlation of the line, which is the linear correlation. So with the scatter diagram, we have those different stages where we have the perfect negative correlation equal to -1, and then we have a perfect positive correlation on the other side, the extreme side, which is equal to +1. And then you can see how it is like, how they differ from each other. I try to make sure that you just get to understand they are not starting from 0, but they're starting from different points. And then you have the some negative correlation, which is probably somewhere in the middle there, close to -0.5. In this case it's -0.4. And then you also have a high positive correlation. So you could have a high negative correlation, which will be around maybe -0.8, -0.9, or you can have some positive correlation which is around 0.3, 0.2. Yes, that's some positive correlation, very little correlation in terms of its positive sense. And then you have no correlation, which is when it's equal to 0. There's no direction, it's not pointing in any direction. It's basically just, it's a perfect scatter diagram. It fits the perfect scatter diagram criteria. And then we now look at linear correlation. So with the linear correlation, it's just focusing on the line, the regression line. So as you can see with the first example, it's a positive linear correlation. Then we have no correlation where there's actually no line, because there's no correlation. There is only a line which shows a correlation when there is correlation. And then we have negative linear correlation, which shows that when x increases, y will be decreasing. That's why it's the other way around compared to the positive one. With the positive one, the x is directly proportional to y, if you know what proportionality means. As x is increasing, y is also increasing, so that's directly proportional. With the other one, where it's the negative linear correlation, that's what we call indirect proportionality. So which means that they are not doing the same thing. As x is increasing, y is actually decreasing instead of increasing, which is the opposite of what we saw. So in most cases, we are going to be, okay, that's where we get our x will be what we call an independent variable, which is why our time was the one that we're mainly focusing on, because that time determined how the mark was going to come out. So the more time you put in, the more effort you put in that time is going to be translated into the mark that you'll get. That's basically the idea, which means that the mark is dependent on the time spent while preparing for the mock exam. Because as you spend more time, you spend more effort, you give more effort to your preparation. So which means that the mark is dependent on the time. That's why we have put the time as the x and then the mark as the y, because a y variable is always dependent on the x. That's why you see that in both cases, with both linear correlation, the x is just increasing. There's no way where we say the x is decreasing. The x is always increasing. It's because it's independent of everything. But the y is dependent on the x. So that's why we see that the y, in the positive correlation, the y is increasing, which is directly proportional. It's directly proportional to the x. And then in the negative, we see that the y is actually decreasing, whereas the x is increasing, which means that indirectly proportional. They are not really related, closely related. And then in no correlation, it means there's no relationship whatsoever. It's just scattered. Each man for himself, God for us all. So we just see that there's no correlation there. So I hope you understand that it's pretty straightforward. I need not to explain much. So now I will leave the next example for you to work on it, attempt it. Pause the video, read the question, try to answer it, attempt everything, use the equations that I was using, follow through with what I was doing, and use the examples that are there, the values that are there, the table that's there, create your own table and all that. If you're able to use a calculator, there's a function called the stats function. On the mode, usually it's on the button called the mode. You press there, or the home, depending on how smart your calculator is. But you have to go to the function of the statistics function, and then you click there, and then you get a selection of stuff. But you have to select the one where it has the equation of the regression line. The y is equal to a plus bx. And then after clicking there, or if it actually writes that regression, if it writes regression, just click there as well, if it gives you the column of x and the y, or rows of x and y, and then you just plug in the values that are in the table, and then you use the other functions of statistics again to get the answers. It will calculate everything for you, from the tables to the line to the correlation, everything it will calculate for you. That's how technology has advanced in our time. We're thankful to technology for that, but let's not be lazy. Let's try to attempt the question, and also try to use graph paper for the regression line, so that you understand what we faced, so that you don't have to use the equation. So let's get on with it, and yeah, all the best in your calculations. I hope you have enjoyed the video so far, and I hope you enjoyed the calculations. So till we meet again, when we look more into this statistics department, the statistics course, so that you get to understand more of how to deal with data, how to analyze data, because we have data around us that needs to be analyzed, so that we get to decide fully how to do things. We get to make proper decisions. We get to predict the future using that data. So all the best with your calculations. Cheers.